Hi, I'm Brett Rexinger, and this is my classroom lesson for the class. As you see here, the objective today is that students will be able to solve multi-step algebraic equations. And then we have an example of a multiple step algebraic equation listed below that students should be able to feel comfortable with handling by the end of class today and by the end of their homework and worksheets and whatnot. We'll start off with a little bit of review. These are just basic algebra problems to solidify your knowledge in the fundamentals of what you need to do when you have, an x plus 5, x minus 12, a 3x, and an x over 5. How do you undo what is tagged with the x? So we have an x plus 5. So what do we need to do to get that 5 on the other side of the equation? We need to subtract 5 from both sides of the equation. Remember, both sides of the equation need to subtract 5. That'll keep them even. And we'll get x equals 12. And now on this one, how do we undo subtraction? We use addition. So on this x minus 12 equals negative 6, we get x equals 6 because we add 12 to each side, and negative 6 plus 12 is 6. It is not negative 18 or anything like that. Yeah, when you add a positive to a negative number, it goes up higher in degrees if you think of it as a thermometer, anything like that. And with 3x equals 21, we have multiplication here. And so how do we undo multiplication? We use division. And so we're going to divide by 3 on both sides. So we have 3 over 3, which is 1. And then we have 21 over 3, which is 7. So we have 1x, or just x, equals 7. Now in this last problem, we have an x over 5. So we have some fraction notation going on. And so how do we undo division, which is what a fraction is? How do we undo division? We use multiplication. So we're going to multiply everything by 5, which is what the denominator is. And so we get 5 times x over 5, which is just 1. So we get x on this side. And then we get negative 10 times 5 equals negative 50. Because a negative times a positive is a negative, which is what we see in our answer. But what if there's more complicated fractions? There we just had an x over 5, which is pretty simple. You just multiply by the denominator. But what if it's a more complicated fraction, like a 3/4 x? And so in this problem we have 3/4 x equals 18. And you guys might recall in previous lessons we talked about multiplying by the reciprocal, and the reciprocal is just the fraction flipped over. So it's instead of 3/4, the reciprocal is 4/3. So we're multiplying by the reciprocal, and remember we need to do that on both sides. Whatever we do on one side, we have to do on the other side, because that's how we keep the balance. So we have 4/3 times 3/4, which is 12 over 12, or just 1. Every time you multiply by the reciprocal, it is 1. So we get 1x, or 12 over 12x, equals 18 over 1 times 4 over 3. And here we can do some cross cancellation. The 3 will turn into a 1, and the 18 will turn into 6. Because 3 goes into 18 6 times, and so we have 6 times 4 equals 24 for that problem. Now I want you guys to take about a minute with your desk partner and try this multi-step algebraic equation for yourself. Give you a couple seconds on that. Okay, what is the first step we're going to be doing? Yeah, we're going to add 11 to both sides of the equation. Remember, both sides of the equation every single time. So we add 11, and so we keep our 2/3 x, so our 2/3 x equals 36, which is what 25 plus 11 equals. And then here we do that same thing, multiply by the reciprocal. And so the reciprocal of 2/3 is 3/2. So we multiply 3/2 on the left side of the equation, 3/2 on the right side of the equation. This equals 1. Every time you multiply by the reciprocal, it equals 1. So we have 1x equals, we can cross this 2 out. 2 goes into 36 18 times, so we have 18 times 3, or 54. So x equals 54. And now we're going to look at a story problem. Story problems are sometimes more confusing because they deal with words, and it's hard to pick out what is actually being asked or what it's being told. And so we're going to read this together. Jane spent $42 for shoes. This was $14 less than twice what she spent for a blouse. How much was the blouse? And so we want to write down everything we know. We know that Jane spent $42 on shoes. So shoes is $42. What else do we know? We know that the 2 times the blouse minus 14, twice the blouse minus 14, should equal that 42. So what do you guys think the equation would look like if we were to set up our own equation based on this story problem? It would look like 42 equals 2x minus 14. So I want you guys to solve that on your piece of paper. Should be pretty standard. We have a minus 14 that we need to get rid of. We're always going to try and get rid of our anything that's not attached to the x first. So we have that 2x, and that is attached to the x. It's so we probably don't want to divide by 2 first. We're going to want to add 14. So when we add 14 to both sides of the equation, can't stress that enough, make sure you're doing it to both sides, otherwise you're not going to maintain the balance. So we're going to get 2x on this side, and on this side we're going to get 56. So 56 equals 2x. And then to undo multiplication, we need to divide. So we're going to divide by 2. So 2 over 2 is 1. So we have x on the right side of the equation. 56 over 2 is 28 equals x. Perfect. And now we need to put that into a statement. What was the question asking? It was asking how much was the blouse. And so the blouse Jane bought is $28. Perfect. How many of you got that right? Stupendous. So now with these new tools that you have obtained, I want you guys to work on page 321, 3 through 19 on, and then 45 through 49. And you guys can work with your desk mate on that, with that. And yeah, if you have any questions, I'll be able to answer them.